So let's discuss the connection between big G and little g. So we talked in the last YouTube about the Newton's law of gravitation. And so what we want to do now is we want to consider a person of mass m standing on the surface of the Earth. And that's what this picture shows. So that would mean the person is a radius r sub b distant from the center of the Earth. And as we discussed in the last YouTube, the force of the Earth on m will be just as if all the mass of the Earth is concentrated at the center of the Earth, because the Earth has this spherical symmetry. And so that means that the force of the Earth on m is the gravitational constant times the mass of the Earth times little m divided by the radius of the Earth squared. And the acceleration, that's this little red vector a, which is acting directly towards the center of the Earth from m, is going to be this force divided by m, by Newton's second law. So if you divide the force of the Earth on little m by m, this little m will drop out, and you're just left with g times the mass of the Earth divided by the radius of the Earth squared. And g, by g I mean big G. So the acceleration experienced by m, if for example m is held up in the air and dropped just above the surface of the Earth, is going to be 6.67 times 10 to the minus 11. That's big G times the mass of the Earth. And so more accurately, I think on the previous chart I talked about this being mass of the Earth being 6 times 10 to the 24th, but more accurately it's 5.97 times 10 to the 24th kgs. And then the radius of the Earth is, again, more accurately 6.38 times 10 to the 6th meters. And so if you do the numbers here, you get an acceleration of 9.78 meters per second, which is very close to the 9.80 that we usually assume, unless of course I'm assuming easy numbers. And the difference between 9.78 and 9.80 has to do with small differences and what one actually uses for either the mass of the Earth or the radius of the Earth. And the radius of the Earth varies somewhat with position. So that's the connection between big G and little g. And as an exercise, what you can do is look up the mass and radius of the moon. You can just Google it. You get the mass in kilograms and the radius of the moon in meters, and use a similar formula to compute what the acceleration of gravity at the moon's surface is, and express it as a fraction of what the Earth's gravitational acceleration is. It's roughly 1/6 of the Earth's gravitational acceleration.